Angela?
Hi, sir.
How are you
I
doing?
use my computer to connect.
It's okay, okay. Where are you now, Angela?
Uh, good. Sorry.
Oh, okay. So it's come with something, all right? Right. So again, goes to your entire screen here and share. Okay. For your information, Nick Danish is preparing the video, the recording of the class yesterday. It takes some time for him. Okay. Not me. So who are you? Who will do that? I can't remember. Darwish. Okay. Me Darwish. All right. Darwish. Sorry for that. Okay. So we move on. Okay, we move on. Desktop. Are you ready, everybody? Are you ready?
Yes, doctor.
Yes, doctor.
Okay. So I'm waiting for 1 or 2 students to join me. Because I can see from my Google chat here is only 30. Only 37. It means 4 more to come. Okay. I can check your attendance. Okay. If you join this talk from, what they call it, from email, I can check. Okay. So I will. This is your proof of your attendance. Proof of your attendance. So we gone through yesterday. Okay. The importance of the elements in resultant, okay, the important elements in the equilibrium, okay, then both for 2D and 3D, okay. Then we move on. We started yesterday with the moment in 2D. Moment in 2D. Okay. I know. May take some time for you to understand the moment. Okay. It is actually a force multiplied by a perpendicular distance to that force. It's perpendicular distance to that force. Okay. Perpendicular distance to that force. Perpendicular distance to that force. Okay, we move on yesterday. Okay, by basic concepts of the calculation of moment. Why it is in clockwise? Why is in the anti-clockwise? Okay, anti-clockwise. Okay. You may want to ask. Here, file, save first. So put here and new slide there. Blank but okay. Okay. If you are sitting at here. Okay, you are sitting at here. Okay, you are sitting at here. Then if you have a moment, okay, a force, I think that direction, a force. Okay, a force. I think from that direction. Okay, it's that direction. Starting from that point, that particular point. Okay. Now I will enlarge it. I will enlarge that force. So make sure I want you to really understand moment. Okay. It's not for static only, not for your test only. Okay. You do more. You do more in mechanical engineering, in aeronautical engineering. So you have a force. Okay. You have force there. Force. Okay. A moment is equal to force multiplied by d. D is a perpendicular distance. Okay. Perpendicular distances. Okay. Regardless of from here. Okay. Regardless of the where the moment where is the origin of the forces. Okay, so where is the origin of forces? So it means that you have to get that distance d. Okay, this is the d actually, d. Okay, that is the d. It's perpendicular distance. Even the force is started further downward. Okay, if even the force is started further downward. Okay, if you are not given D, that's why what we did so far in the class yesterday, what happened? We resolved the force into X, F in X, and F in Y. Okay, F in X and if F in Y. Okay. So when taking moment at point D, okay, when taking moment at point D, okay, moment at point D, sorry, moment at point D also that equal to, okay, force okay, force X, okay, force X multiplied by the perpendicular distance from there to that force is, you can extend the force is you like because it is a vector. Okay, you can that force, and this is your, say, D1. This is your D1. Okay, multiplied by D1. Multiplied by D1. Okay, let me correct my small erase there. Let me do D1 here. Okay, multiply by D1. D1 here. D1. D1. So, same thing for the force 2. Okay. For the first force 2. Regardless where the moment started, okay, it doesn't matter, but you need to get the perpendicular distance to that. D2. Okay. Plus Fy multiplied by D2. Okay, that is the concept of taking moment for the concept of taking the perpendicular distance for the moment. Okay, since both of them, all of the forces in anti-clockwise, then you may multiply by all those by -1. Multiply by -1 because it is in that one giving you a clockwise, that one also giving you a anti-clockwise also. And so that is a concept moment. And on here, I will share the slide today. This one. So same thing. So we did here until yesterday. Until yesterday, to get a moment at point E. Okay, to get a moment at point E. Yesterday. Okay. So I am asking you to get moment at point D. Can someone tell me what is moment at point D then? So what to do now is I will copy it down. Okay, so paste there. So I'm asking you now to get moment at point D and B. Erase, medium erase. So I move down, I copy all of them. Should I do that here? A system where you have a system that you have a moment and you have a forces. Okay, a system where you have a moment and also a forces. Hello, can you listen me? Hello.
Yes, doctor.
So okay, can you listen to me? Okay, what is the second question is what is the moment at point B and moment at point A? B and A, right? I asked you yesterday. Moment at
B and D, sir.
E and D. Okay, do that. What is moment? Let me do this together again. Moment at point B is equal to sum all those forces in negative 15 minus 20 plus 100. All this is component of moment, already moment. Multiply by distance there, everything it goes to zero. And the way we mark it, because you don't understand what the principle of the moment. If you do that, I don't think my student will do that. Okay, don't do that for me. Okay. What else? What are the elements that you have? Plus, negative cos 10 cos 30 degrees. Multiply by what? Multiply by what distance? That force?
5.
No. You're taking moment at where? Moment at B. Okay, moment at B. Okay. Negative
3.
3, yeah, negative that one, What else you have? Plus what? 10 sine 30 degrees multiply by what? Pandai. What else do you have?
5.
What? Which 5? That one. This one. This
Uh,
component.
F4. The one at point H.
Okay. What else you have? This one give it positive moment or negative moment? This one. 25 sine. You're sitting at point B. Hello?
Negative.
Negative 25 sine 25 multiply by what distance here?
6.
6.
What else you have?
25.
That one positive or negative? That one
Positive. 25
Pandai.
cos 25.
cos 25 multiply by
7.
7.
And what else you have? Plus 5
5.
multiply by
9.
9. Can you get that one for me? Moment at point B. Moment at point B. Do that for me.
.204.23.
Can you speak louder, sayang? Cannot hear you.
204.23.
Cannot hear you. Hello? I'm talking alone? M at point D is what? Get that calculation for me. Moment at point B first. Moment at point B first. Ada kelas tak? Moment at point B. Tell me. Hello? Hello? One 139.23 Newton meters. The rest still sleeping. 139.29, 139.23, 139.23, 139.23 Newton meter. Okay, get to me moment at point D. Do that now for those who just do nothing yet. Get the moment at point D to me. Aduh. Dah sana tak apa. Tak apa sebab ada. Hello, can you listen to me?
Yes, sir.
Yes, sir.
Moment D. What is moment D? 72.3. 72.3. 72.3 MD. Also, MD is 72.3 Newton meter. Okay. So what to do now is I will give you 5 minutes, okay, to revise all the calculation of moment. So, okay, make sure you crystal clear all this moment calculation. Make sure you crystal clear on how the elements that you have to do when doing the calculation. Ask me if you don't understand.
Sir,
Yes.
for MB, the answer is 204.23.
But all these elements are correct, right?
Yes.
So the answer is not right. So can put in the chat. I want to see the majority of the moment at point B. Moment B again. I want to know the moment at point B. Put in the chat your answer. Moment B. Put more. 204.23. 204. Okay, everybody get 204.23 Newton. 204.23. Okay, so I have to follow that majority. So medium 204. Right. 4.23 Newton. Okay. It should be okay. Should be okay. Right. So, this is a system. You can see that one. Okay. That example, you have only few forces. Few forces X. Few forces X on several points, then it can give you moments, different moment at different points. See, just only forces. The second one, you can see also if a system is X by several forces and also several forces and several moment, you can see that also can induce a moment, different moment at different points. Okay, different moment at different points. Okay, let me move on to this another structure. Okay, this another structure. Say that this is point A, this is point B, this is point C, D. So this is A, this is B, this is C, this is D, this is E, this is F. Understand me? Okay. Okay. So you are given distances all here, all are given. Say there to there is 5 meters. There to there is 6 meters. There to there is 2 meters. Okay. There to there is 2 meters. Okay. Look at me carefully. I will go very slow. This is understanding. I am now improving your skills of engineering in taking a moment. Okay. Go very slow today. Are you ready to go?
Yes, sir.
Yes.
Very good. So I apply. I apply a twist here. Apply moment here. Moment 1 is equal to 10 kilo Newton meter. All are clockwise there. Moment 2 is 20 kilo Newton meter there. Moment at point E there is back to 15 kilo Newton meter. Okay, all are clockwise there. And then I apply a clockwise there moment at point B. All are clockwise. B, C, D, E, F. Okay. So M1, M2, this is M3. M4, okay, that equivalent to say 14 kilo Newton meter is equal to 45 kilo Newton meter, and here is 10 kilo Newton meter. Okay. What is a moment at point A? Moment at point A. Total moment at point A. Total moment at point A. Total moment at point A is sum all the moment at point A. Sum all the moment at point A. It is to the system. It is 10 plus 20 plus 15 okay, minus 14, minus 45, and minus 10. So you will have total moment at point A that equal to what? Get to me 10 plus 20 plus 15, all those?
Negative 24.
Negative 24 kilonewton meter. Okay, negative 24 kilonewton meter. You're taking moment at point F. Summation moment at point F. Total moment at point F. Okay, that also is equal to 10. Okay, plus 20 plus 15 minus 14 minus 45 minus 10. You will get a summation of moment at point F equal to what? Equal to negative 24 kilonewton meter as well. So in this case, you can see moment, summation of moment at point A equal to summation of moment at point B, summation of moment at point C equal to summation of moment at point D, summation of moment at point E equal to summation of moment at point F. It's telling you what? It's telling you in a system, okay, in a system of structures or rigid bodies, if you apply a moment only, to the system, okay, are you listening to me?
Yes, sir.
Yes, sir.
If you apply a moment only, the summation of moment everywhere in the system is consistent. Okay, everywhere in the system is consistent. Okay, it's not only a moment at point A. Okay, it's not only point A, it point here, everywhere here. Everywhere in the system, in the structure, are the same value of a moment. Okay, if you apply a moment, only to that system, okay, you will use this a lot in the engineering soon. If you apply moment only, okay, understand me?
Yes, sir.
Very good. Okay, copy. You move it down. Okay, we move it down. So, in case, okay, now it's a different case. If we do erase here, I do erasing here, erase every part here.
So,
Yes.
so we can conclude that the system is rotating anti-clockwise.
Yes, anti-clockwise.
But at what point?
Everywhere in the system. Everywhere.
So there's no pivot point on the system.
No pivot. Yes, you're asking that. We're going toward that.
Oh, okay, sir.
After next week, we will do 3D moment. Okay. And then before 1 week before holiday, we will go to your question.
Okay.
Okay.
Okay, thank
Can
you.
do? You are expecting me what to do. Very good. Okay. We will do right. But unfortunately, okay, if in that system, if you apply a force only here, force 1 that equal to 100 Newton, everything will change. Okay, everything will change. Moment A moment B is unchanged. Okay. So you do the moment at point A. So I write it here. I read it right here. Summation of moment at point A that is equal to still 10 plus 20 plus 15 minus 14 minus 45 minus that equal to what is it just now? Negative 24, if I'm not mistaken, kilo Newton meter. That doesn't involve with the distance. But if you do moment at point C, okay, summation of moment at point C that equal to 10 plus 20, okay, plus 15 minus 14 minus 45 minus 10. What are the elements that you should add on if you're taking moment at point C now? Tell me.
F1.
Yes. Yes. Now you have plus F1. No, it's simply that as 100. Okay. Plus. Okay. Plus by 100. Plus by positive 100. Multiply by what distance there?
6.
It's going to give you. Can tell me what is the answer for that? Tell me what is the answer for that. No, 600 tolak 24 lah. 5 what?
500. 574.
6. Right? 7, 5, 7, 6.
7.
Newton meter. Can you get me moment at point F? Moment at point F. What is it? Can tell me what is moment at point F? Tell me. Do that. It should be more. Tell me what is moment at point F?
776.
Wow, 776. Nice answer, 776 Newton meter. So kilo Newton meter, sorry. So you can see if you put a force, if you put a force, okay. If you put a force, the moment is not consistent anymore. Moment is not consistent anymore. Okay. Moment is not consistent anymore. If you put a force. Okay. Right. Very clear. Clear about the calculation of the moment. If clear, we move on. Okay, a system. We call it a couple. Couples. A system that having, okay, one force and one moment. Couple lah. Dulu banyak student couples. Couples. The library asyik couples. That is mean by couple. Okay. Okay. It's one force and one moment. Such as what to do now is you have a structural like that, a structure like this. Oh, this is not good. This is not good writing there. Point A, Point B. So this is B, this is C, this is D, this is E, this is F. Okay. Say you apply force. Okay, you apply force at many points. Here you apply moment 1, moment 2, okay, moment 3, force 1, force 2, and force 3. Force 3. Okay. A couple is where a system that you want to say, you want to transfer all this moment and all these forces transfer to a where should I go? Where a system that you want to transfer all those forces, okay, many forces to one point only. One point only. Say that this is point A, point B, point C, point D, point E, point F. Okay. You want to transfer all this moment into point A only, or point B only, or point C only, or point D only, or point E only, or point F only. So it's going to be big moment, okay, mother of the moment there. Point A, say that. Point A, M A, okay, moment at point A, okay, and a force there, which are theta. This is couple. Okay, this is couple. A couples at point A. At point A, couples, okay, couples at point A. Couples at point A. Where you transfer all those moment, all the forces into point A only. Into a point A only. To point A only. Right? To where? To point A only. So example here. Okay, so determine the forces, always forces and couple system at point E. Point E. Okay, you have structure like this. You have structure like that. Okay. Have a structure like that. Okay. Okay, yes, there's a system like this. Then 2 meter there. This 2 meter here. 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 2 meter there. Okay. All right. All right. So this is point A, this is point B, this is point C, this is point D, this is point E, this is point F, this is point H, this is point I, this is point J, this is point K. This is point K. Okay. Determine a point E. Okay. At point E. Are you with me? Clear?
Clear, sir.
Hello.
Yes, sir.
Very good. So you apply forces, many forces. So MB 2 Newton meter. Okay. MD 10 Newton meter. MK 8 Newton meter. Here is 10. Okay, here is 10. 10 Newton meter. Newton meter. Okay. Here is 10 Newton meter. Okay. No, give me 1 second, okay? Control Z, Control Z, Control Z, Control Z, Control Z, because I want to redraw it again soon. Control Z, 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 Control Z. So let me erase again, okay? Erase. Do this. Okay. I'll do it again. A reason for that. I'm not confusing you again. Anything. Okay. This is point D just now. D just now. Okay. All right. Come back. What is the moment just now? You remember? What are the moment that I applied just now?
At B2.
SB 2 Newton meter. What else?
D10 clockwise.
What was 10? Then Newton
K8.
anti-clockwise, right?
Yeah.
K is what?
8.
8 Newton meter. What else? So nothing, right? Moment at H, say that 2 0 Newton meter. You twist that one, and at point E, you apply force. Point E, you apply force. Uh, 10 Newton. Okay. At point K, you apply force here also. 15 Newton. At point I, you apply a force downward. Okay, by force downward. Okay, so tell me what value you want. 10 Newton meter, 10 Newton and 18 Newton there. Okay, that's it. That's it. Okay, that's it. So you want to transfer all this moment, okay. Yeah. Okay. Peace. Okay. All this moment into point E. Okay, at point E. Okay. It means that you want to transfer all the moment and forces at point E. At point E. Okay, point E. Point E only. Okay, so you just summarize all the moment in X. Summation of force in X at point E. Total moment as what you did in resultant. Total force in X is, you have what? You have in the system is 10 plus 15 in X. That's it. Is equal to 25 Newton. Okay. Then what you have? What else you have? Summation of force in Y at point E, that equal to negative 18 minus 10, that equal to negative 28 Newton. Okay, there is sum of the resultant of forces at point E. Okay, forces at point E. Okay, sum of the forces at point E. So in X is 25. Okay, in X you will have sum of the forces in X is 25. Sum of force in 28. So then what to do now? If you have to get, since for a couple you have a system, have a moment and one single force and one single moment. Okay, what to do now is you need to get a summation of moment at point E. Summation of moment at point E. Okay, that's equivalent to what else you have? Okay, so you will have 20 plus 2 iris, medium iris. You'll have 2 plus 10 minus 8 minus 20 point E minus 15 multiplied by 2. What else we have? Minus 10 multiplied by 2 minus 18 multiplied by 4. Can you tell me what is moment at point E? Summation of moment at point E. Hello, are you with me?
Yes, sir.
Still working on it?
Dah dapat negatif 138.
Okay. What is the moment there? Negative? Tell me again. Negative?
Negative 138.
138 Newton meter. So you bring it over, okay, bring it here. So Fx is Fx, total Fx 25. So you know, summation force in x upon E is negative, is what, how much just now? Is 25, is positive 25. Summation of force in y at E is equal to if negative 28 Newton, and summation of moment at point, what they call it, E. If what, tell me again, I'm aging, I can't remember. 100?
138 negative.
138 Newton meter. It is negative, right?
Yes.
It is negative. So, moment, total moment at point E. Total moment at point E is moment itself, moment at E. You bring it all over, moment. Huh? You bring it all over from here. Okay. From this complicated moment, you apply moment everywhere. You apply force everywhere. So a total moment at point E is given by M E is equal to where should I write? So moment E is moment E equal to is equal to 138 Newton meters. Okay. Then you force in X. You have a force in X at that particular point. At that particular point, you have, okay, Fx is 25. It's too long. Fx is equal to, depend how long you can learn to do that. F in X is equal to, okay, how much? 25 Newton. As what we did in the resultant. Get the resultant at point, and then Fe is negative 28. If 28 Newton there. Okay, negative 28 Newton there. Then get to me the resultant of these two forces. Get to me the resultant of these two forces. Get the resultant of these two forces. So it's going to be a Fe. And theta. Okay. So this is a total force at point E, and you have a theta is what? This is, we call it as couple at point a couple at point E, a couple at point E. Okay? You have a single force and single moment that acts at point E. Okay, give me that a theta, give me that resultant. Give me theta, get me the resultant there. Sorry. Tell me what is the FE then?
37.54 Newton.
37.54 Newton. And theta is what? Theta is what?
Negative 48.24.
You shouldn't put negative there. Theta is absolute value.
48.24.
48.24 Newton. Okay, degrees. Degrees is not Newton. Okay. Okay. That are you crystal clear about the couples? You from a system, okay, from a system, okay, in the structure A, B, C, D, E, F, G, H, I, J, K. You have multiple forces apply on it. Point E, okay, okay, point E. Then at point A, everything. You want to transfer all those moments and forces at point E, which are one single force and one single moment at point E. Okay, so this is the force and moment at point E. Okay, now if I am asking you, now change the question, determine the couple force and couple system at point. Okay, at point, now move on, erase, medium erase, at point F and J. F first, we do point F first. Point F. Do that. Now, what is the parameters unchanged? E and J. E and when we compare E and F, what is the parameters unchanged? Tell me. What is the parameters unchanged in the couple? Which one? Force or moment unchanged? Low.
Moment.
Moment.
Sayang. Force unchanged.
Force.
Force unchanged. Force unchanged. Okay, in the system, force is unchanged. And you do moment at point F is only a moment who change. Okay, at F. Okay, at point F there. Okay, do that now. Get the moments. Get the moment. Okay, summation of moment at point F. Tell me what is it. Tell me what a moment at point F. Okay, you know summation of force in X at point F, summation of force in Y at point F are equal to everywhere in the system. Okay. Here is Fx 25, 28. 25 and negative 28. 25 Newton and negative 28 Newton. Okay, 25 MA. Am I right? 25 and negative 28. Okay, get the moment at point F. Tell me what is the moment at point F. So today I will stop at 9 past 30 minutes past 9. So you have more time for revision and so on for the other subject. Okay. Because I'm taking extra time yesterday. Okay, I'm taking extra time yesterday. Okay, I shouldn't do that. It's time for you to do some calculation and this. Get a moment at point F. Moment at point F. Then you know here is at point F. Okay, point F. The force is unchanged. Force is here. Point F also you will have force F. Okay, couples at point F. COUPLE at point F. Okay, that is F is not changed. Okay, total force is not changed. F is equal to F that equal to, what is it just now? 37.45. 37.45 Newton, and theta also is unchanged. Theta is equal to 48.24 degrees. 48.42 degrees. And what is moment at point F? Moment at point F. And then it would give you couple at point F. One single forces and one single moment there. Okay, one single forces and one single moment there. Tell me what is MF then?
136 Newton meter.
So is it positive or negative?
Positive.
So now it's giving you a positive. Okay, moment 136 point what?
Newton meter.
136 exact value.
Yes, sir.
There's no decimal point. So Newton, no, I should erase it. Write it properly. If no, student will complain in the UTM confession. 136 Newton meter. Okay. See a couple system, mostly the force is unchanged. Okay. The only change is the moment. You can see from that system, you transfer moment to point E, you will have a system like this. Moment at point E. When you transfer moment at point F, okay, point F, the magnitude and the direction of the forces is unchanged. Okay, except the moment. So this is, we call it a couples. Okay, this is, we call it as a couple at point E. Okay, this is a couple. Angela,
Yes,
you dah ada couple belum?
Hah?
You dah ada couple ke belum?
Tepat.
Tak ada,
Ini itu belum.
Itu belum kena cari yang kaya tau sekarang
Oh.
I'm just joking Angela Jangan marah, ha?
Okay.
I don't know what else I can do to make you happy. Huh? Angela still single, ha? Angela, ha? Gurau je, ha? Jangan marah, ha? Okay, ha? You understand couple, ha, Angela, ha?
Yeah.
Very good. The couples at point E. Couples at point E. Okay. Then it's a couple at point F. All right. I can give you we have 14 minutes. It's your time. 14 minutes of your time that you pay. The time that you pay. Okay. Oh. Okay. What should I do? Angela. Oh, Angela.
Huh?
Don't write in the UTM convention lah. Lecturer tanya saya ada boyfriend.
Tidak.
No, your seniors, Your seniors, They write everything tau. They write everything there. They write everything, and that Facebook everybody can read now. You know? Even people in board of engineers also can read. You know, they write about the toilet kotor mah. They write about the makanan tak sedap mah. Duh. Okay, now exercise. You do exercise. Okay, exercise. Okay. We have a bar like that. You will ask me why you always using bar and structure like this. Huh? The distance all are given like this. Why the system like this? Because in engineering soon, you will do a lot of calculation like this. Indirectly, I'm giving you a structure like that. How come it doesn't go? Okay, so a little bit distant there. Balkis?
Yes, sir.
Dah ada ni dah? Couple?
Apa, sir? Tak ada.
Couple. Ada,
Tak ada.
Jangan marah,
Tak, sir. Okay.
Danish mesti ada.
Single masih, sir.
Yalah. Danish nak cari orang Tanjung. A structure like that. A structure like that. Okay. A structure like that. Okay. A structure like that. Okay. You are given here the distances there. Uh, 5 meters, 5 meters, 7 meters, there to there is 4 meters, and this angle is let's say 40 degrees. So you apply a moment. Okay. Apply a moment. Okay. Then apply a force. Okay, force here is 20 Newton. Force here is 20 Newton. Here is 15 Newton meters. There is 15 Newton. Okay, you apply again here. moment again here, 18 Newton meters. And you apply here force is equal to, say this is force 1, say this is force 2, moment 1, moment 2, force 2, force 2 is equal to force 1, force 2, force 3, that equal to how much you want? 20, 15, 30 Newton. Okay. Here giving angle here is 50 degrees. Okay. Then here is point A. Okay. Get me a couples at point A. Okay. Couples at point A. Point A. Do that now in 10 minutes. Okay. Do that now in 10 minutes. Do that now in 10 minutes. Do that now in 10 minutes. Okay. Get a couples at point A. So I'm not going to guide now. Try to do it on your own. Try to do that on your own. Okay. Try to do that on your own. Okay. Do that. Okay. Faster. Do that. Okay. Do that. Get a couple at point A only. Then you are done today. Get a couple at point A. I want the answer. Okay. What is I just want to give me the moment A resultant at A and theta at A. That you are done today. Then I let a file save. Hello, how long you have to do that? Hello, how long you trying to do that? All the distances are given there. 4 degrees 4. Here, need to get that distance there and that distance there. And not given today. I'm not going to teach. Okay. So as simple as you need to get that these distances. Okay. From there and there to there. Okay. I want the answer only from you. I want the answer only from you. Now I give you another 5 minutes. So that means that I'm taking another 5 minutes from you. Okay, so don't blame, don't.
Sir,
yeah.
my MA is negative 398.72.
Terus saya yang tak dengan negatif
398.
98.72
72.
Newton meter. Our resultant is what?
54.89.
Then theta
47.97.
7.97.
43.97.
43. Are you getting the same answer with him?
Yes, doctor.
Yes. So if you're getting the same answer with him, that means, okay, remember me, a couple maybe asked in test 2. A couple maybe asked in test 2. Okay, test 1 is simple as resultant 2D. Question 2 is equilibrium 2D. And then question 3 is as simple as what we call it as 3D, resultant or equilibrium. Couple will come out in test 3. So you have here negative, okay, negative 398.72 Newton meters, and then your RA is there, okay, is a 54.89, and then the theta here is 43.97 degrees. No, degrees sayang, it's not Newton there. So there is iris here. Okay, there is iris there. Okay, when you are given a couples like that, you are given like that, okay, when you get the moment, you have to draw, you have to redraw, just sketching the object and put them and put the force and moment in that particular structure. Okay? You have to redraw again, which moment, put moment, force, and the theta. Okay, but
So-
if you left, yeah,
The arrow should be above the x-axis, right?
above.
Oh,
Okay, it's yeah. Okay. So I thought that same with just now. So R 54.89 Newton. Okay, this is R theta. This is your theta. Okay, this is your theta. So I thought that you get the same as what we did in the previous example. Okay, you are the good one, too clever. Very to calculate all this. Okay, you have to redraw the rig again. Okay, that's the end of our meeting today. So, if I will share that slide today. Right. Let's stop presenting. Okay, so more exercise, you can find it in the book given sent to you. Okay. Right. Is there any question?